Okay, hi, I'm Amanda. This is Math 2410 at MCC, and we are looking at a mean value theorem. So I've pulled this problem number 16 from my homework set. This problem asks us to find the values of C guaranteed by the mean value theorem. We might have more than one. For the function f of x over the given interval from 4 to 9. So the key is we're working with that mean value theorem. So I have the mean value theorem here on the right. It says that as long as f is continuous over a closed interval, then there exists a c in the closed interval that satisfies this equation. So this is really the equation that we want to solve for c. So let's go ahead and write that out. So we have the antiderivative from a to b of f of x dx equals f of c times b minus a. Now let's fill that in for our given information. So our a to b is 4 to 9. So we're going to have on the left the antiderivative from 4 to 9. Our f of x is 4 square root x dx. That's our left-hand side. Our right-hand side is going to be f of c. So this is going to be 4, plug in c for x. So we have 4 times the square root of c. And then for b minus a, we're going to have a 9 minus 5. And then for this equation, we just want to solve for c. Okay, so we have an equation, but we probably want to simplify it before we try and find what c is, because there's a lot of things. But some things to keep in mind. This left-hand side, this is going to be equal to a constant. So really, we are able to solve for c as a constant. We can get it as a number. But let's go ahead and break down that left-hand side first. So here I have the antiderivative from 4 to 9 of 4 square root x dx. And I'm going to go ahead and rewrite that square root of x as an exponential. So this becomes the antiderivative from 4 to 9 of 4x to the 1/2 dx. And then I'm going to apply the power rule. So this becomes 4 to the 1 plus 1/2. This becomes 3/2 divided by 3/2, or multiplied by 2/3. From x equals 4 to 9. And because we're dealing with a definite integral, we don't have to worry about that constant. Okay, so 2/3 times 4, we're going to end up with an 8/3 x to the 3/2, and this goes from x equals 4 to 9. The nice thing is that 4 and 9 are perfect squares, so we're going to deal with some nice round numbers. I'm going to actually continue writing down below. So 9 to the 3/2 power, 9 to the 1/2 power is 3. Cube that, we get 27. So we have 8/3 times 27. And then we have 4 to the 3/2 power. We have 4 to the 1/2 power is 2. And then to the third is 8. So we end up with, if you wanted, we'd have 19, 8 times 19 over 3. End up with a 152 over 3, which is an approximation. So that's just our left-hand side. So on the left-hand side over here, now we have 152 over 3. So it's a constant, that's nice. And then let's fill in, we still have on the right-hand side, we have 4 times square root c, and then 9 minus 5, we can make that into, oops, that should be a 9 minus 4. 9 minus 4 becomes 5. You may have caught that earlier in the video. So then on the left-hand side, now we just want to solve for c. So it looks complicated with that square root, but really it's not. We can 152 over 3. We get that equals 20 square root c. From there, we can divide both sides by 20. Okay, so that's gonna give us not a nice perfect number, but that's okay. On the left-hand side, we get 38 over 15, which isn't a perfect square, but it's kind of hard to get perfect squares. And then we just square. So just solve that, we can square both sides. That's okay that it's not a perfect square root or perfect square, so then we just square that, and we end up with 1,444 over 225. So we can approximate that if we want to, but that's going to be our C value. And I think it tells us to approximate to 4 decimal places. Yes, so I've been slacking on that. So if you haven't been doing that, I haven't been doing it, you will want to make sure you calculate that correctly. So then on the left, this is going to be 6.4178. It's approximately C. So I apologize. For example, 17, I don't approximate to 4 decimal places, I'm pretty sure. All right, thank you.